Question 8 is a financial maths question. We're told that the profit in year 1 for a company is €50,000. 2018, the profits increase and form a geometric sequence where the ratio is greater than 1. And in 2019, the profit is 50,000 times R, and in year 3, 50,000 R squared. And we want an expression for profit in year N, which let's just write out our sequence. 50,000, 50,000, or 50,000 R squared. So you can see here that this is term 3 and we have a 2, so we're dealing with an n minus 1. Term 2 we have a 1, and term 1 we would have R to the power of 0 if you want to stick that in. So year N is 50,000 times R to the power of n minus 1, the number previous to the n. Part A. Part B, the model predicts in year N the profit made will exceed, it's going to be greater than 200,000, and you can see here it's a log question if you didn't know already. So your rules of logs are really important. So 50,000 times R to the power of n minus 1 has to be greater than 200,000, not equal to, just greater than 200,000. Dividing by 50,000, we're going to get R to the power of n minus 1 greater than 4. We're going to get the log of both sides, so we bring n minus 1 by the log of R would have to be greater than the log of 4. If we multiply the left hand side, we'll actually divide by the log of R here, n minus 1 is equal to the log of 4 divided by the log of R. And here you can see that's what we're looking for. So n is going to be greater than, if we bring the 1 across, the log of 4 over the log of R plus 1. That's part B. Part C, you're asked to use the model when R is 1.09 to find the year in which the profit will exceed 200,000. Well, this is just a substitution question. The log of 4 divided by the log of 1.09 plus 1. Obviously this is calculator use. Typing this into your calculator, you're going to get 17.08. So n obviously has to be a natural number, so n will be 18, so in the 18th year. That's part C. And it does ask us to find the year, so let me read the question carefully. Find the year. It's the 18th year after, when did it start? 2018. You see here it started in 2018. So the 18th year after that will be 2035. 2035. Part D of this question, find the total profits after 10 years from 2018 to 2027, giving your answer to the nearest 10,000. Well, this is the sum of 10 payments. So S of 10, or S of n, is equal to A times 1 minus R to the power of n over 1 minus R. You should know this formula off by heart at this point if you've practiced enough questions. So let's just write our sequence out again. A was 50,000. The next term was 50,000. We're dealing with the 1.09. So you can see my R is 1.09 and my n is equal to 10. So just filling this information in, typing it into our calculator will give us the answer. 50,000 times 1 minus 1.09 to the power of 10 divided by 1 minus 1.09. And we type that into our calculator, it's going to give us 759,646, which is really close. You can see here 760,000 euros to the nearest 10,000. We're asked in part E to draw a graph to show the profits over time between 2018 and 2027. Now, it doesn't say cumulative profits, so let's just do each individual year here. So we have year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A lot of information going in here. Now just calculator use. 50,000. Type in by 1.09 and you're going to get 54,500. And just keep doing this all the way down. You're going to get 59. I'm just going to round them off to the nearest euro. 405. Then you're going to get 64,751. Then you're going to get 70,579. Then you're going to get 76. 931 83 855 91 402 99 628 and finally 108 595. Now in an exam I don't have graph paper on this device, but we want a pretty straight line, so we have 10 years. Now I'm going to start at 50,000 here. Just going to mark off this start at 50k here, and we have 10 1 2 3 4 5 6 7 8 9 10. Good division. And we're going up to 108, so let's go up in maybe, we go up in 10,000s here. So 60, 70, 80, 90, 100, 110. You're going to use graph paper here and get this exactly. So 60k, 70, 80, 90, 100, and 110. And if we plot our points, let's see how it looks. It's exponential. So we're going to get 50. I'm going to get a 54 500, so halfway up approximately. 59 405, so just on the 60 line. 64, so about 65. Behind it there. 70, just over. And I'll put my values in down here as well. I better put my year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make it right underneath years since 2018. On year 6, so we're at 76. Up there. Year 8, year 7, 83. It's a very slowly growing exponential curve. It's not like the coronavirus. 91 for year 8. Year 9, 99. Starts to go a bit steeper. And year 10, 108. So obviously with graph paper, you're going to have this exactly. Try and connect all the points. And that's your graph for the growth over time. Part F of this question is a lovely proof, the proof of the geometric series. I think the nice way to try and teach you how to remember it, if I just cross multiply here, Sn by 1 is Sn, and Sn by or is or Sn. So if we can get Sn and or Sn and take them away from each other, this is the key to this proof. So let's write Sn here. Sn is equal to the first term, and then the first term by the ratio, and then the first term by the ratio squared, all the way up to a or to the power of n minus 1. Okay, what's or multiplied by all of these terms? Or times Sn. So or Sn is equal to, well, it's going to be a, this one times or, so I'm going to line them up here. It's going to be a or plus a or squared. And what will the last term be? The last term will be this one multiplied by or,